we are looking at right here how we're going to go about drawing ionic bonding. So here is a picture of two things that are bonded together, and those two things happen to be ions. This right here is a calcium ion. This right here is a sulfide ion. So the question is, how did we come up with this ultimate picture? So we start out and we're given two things. The calcium element and the sulfur element are the two elements we're going to bond together. To draw a picture of them, we're going to put their element symbol at the center. We're going to take all their s electrons, and there's only two of them, and they'll go in the top position here as dots. P holds 6 electrons, so we're going to use 2 to the right, 2 to the left, and 2 to the bottom, so that those 6 dots represent a potential of 6 electrons. So we have our first element here, calcium. We go to the periodic table, and this is the period that calcium is found in. There's the calcium box. And we only care about the outer electrons. That means that we're only going to count the element squares that are going to lead us to the element in question within the period. So here's the period that contains calcium, and then here we have 2 squares, and those 2 squares represent 2 electrons, and they come from the S block, so they're going to go up in the top here. So when I go to draw calcium, because it's got 2 electrons in the S block, it's an S2, and here are the 2 dots representing the 2 electrons from these 2 squares. Then we have to do the second element that we're interested in, which is sulfur. So here is the period from the periodic table where we can find sulfur, and it's over here. So I have 2 boxes representing 2 electrons in the S block. That makes it S2. And then I have 1, 2, 3, 4 that are part of the P block, so that's why it's a P4. So I have 2 electrons or 2 dots on top representing the 2 s electrons, which came from these 2 boxes. And then I have P4 because of these 4 boxes leading up to the sulfur. So that's altogether 6 dots that surround where the sulfur is. In order for an ionic bond to form, we need to have one element lose and one element gain. And it always works out that the metal is always going to be the loser and the non-metal is always going to be the gainer. So do you see the remnants of the zigzag line right here and the remnants of this zigzag line right here? On the left are the metals, so calcium is going to lose. On the right are the non-metals, so here's the line. Sulfur's on the right as a non-metal. So these 2 dots are going to be lost, and they're going to be given to this sulfur atom in the empty spot. So here in this picture, you can see that I've taken the 2 calciums electrons, and I put them right here to make this guy have a complete set. Over here now, we only have a calcium symbol. The dots, they're gone. And that means it has lost 2 electrons and acquired the charge of 2+. So we put brackets around it and a charge of 2+. So once we fill in these 2 empty spots here with the 2 electrons that came out of the calcium, now this guy has gained 2 electrons and he becomes a 2-. And it looks like I have a typographical error right there. It says 2+, so I better fix that. Okay, I'm not going to be able to fix it. So this is supposed to be a 2-, and what does a minus do with a plus? It attracts. And so the plus and the minus are going to be bonded together because oppositely charged ions are attracted. Okay, that worked out perfect because these 2 electrons right here fit perfectly in those 2 spots right there. Here's one that involves calcium and bromine. So calcium is right here, bromine is right there. We've already seen how calcium is an S2 because it has two squares in the S block. And we've seen that it has two dots because of the two blocks representing the two electrons. Now when we go to do iodine, we have 2 for the S block, and then we have 5 for the P block. So if you look at these yellow dots here, I've got 2, 4, 6, and then here's the 7th yellow dot. And because of the 7 places, there's one empty spot right here, and this one electron fits there. But do you notice how it's not a perfect fit? I still have this other dot over here. And this other dot has to go somewhere because calcium is supposed to lose all of its electrons, not just one of them. So I need to bring a second iodine into the picture so that this second dot has a place to go. So these were not a perfect fit. I needed to have 2 iodine in order to get both dots to have a place to go. So when this calcium loses its 2 dots, it's going to acquire a charge of 2 plus. And then when these two guys here pick up this 1 dot here and that 1 dot there, they're going to acquire a charge of 1 minus. And it's pretty hopeful that you'll understand this, but pluses attract minuses. It's that simple. But I want you to notice that you can't be willy-nilly about how you put them together. So here's a 2 plus, here's a 1 minus, and here's a 1 minus. These two 1 minuses are not going to be attracted to each other. So don't ever put 2 ions side by side that have the same charge, because they are not going to be attracted. There will not be an ionic bond right there. So we have to put negative, positive, negative. We have to flip the charge every other place so that there's an attraction here between opposite charges and there's an attraction here between opposite charges. So that's why this picture is wrong. It doesn't have opposite charges hooked up right here. That's 2 negative charges that are side by side. So you have to properly align them right here. And that is how you draw ionic bonds.